Okay, so in this lesson we are extending our understanding of solving and finding zeros of polynomial functions and equations. In this lesson we talk about the fundamental theorem of algebra, which basically talks about the solutions and how we find solutions of a polynomial equation or find the zeros of a polynomial function, which zeros and solutions are the same thing, just shown in different ways. So if a polynomial has a degree of 1 or greater, it has at least one solution. Okay? So if it has a degree, it has at least one solution. So if it has a degree greater than 1, or greater than 0, sorry, the degree tells you how many solutions it has. Okay? And there are times where we have repeated solutions. So if we have a repeated solution, it is counted as 2 solutions. Okay? A solution that's repeated 3 times counts as 3 solutions. So this is just this table breaks down that a linear function has a degree of 1, it has 1 solution. So it's making that connection that the degree tells you how many solutions there are. The thing I want you to notice here is that in this polynomial, there are such a thing as imaginary solutions. So before, the solutions we found were all real. Today we're going to find a mixture of real and imaginary solutions. So for example 1, it's a pretty simple concept. This polynomial has a degree of 3, so it has 3 solutions. And that comes from the 3 right here. Part B, how many zeros does it have? That comes from the first term. It has 4 solutions. So when we talk about solutions, we're just looking at the degree, and that helps us narrow down our solutions. So in example 2, I'm going to show you how I want you to tackle problems like this. So the first thing I look at is if I'm finding all the zeros, I need to know how many zeros there are total. So for this polynomial, there are 5 zeros. Okay? And what I'm going to do next is to find the real zeros. I'm going to graph this in Desmos, find the x-intercepts, and we're going to talk about what happens then. So I'm going to kind of pause my recording, and I'm going to pop up the Desmos screen and show you the x-intercepts, and then we're going to use those to find the other zeros. Okay, so looking at our graph, I see 2 x-intercepts. So I'm just going to write my solution, my real solutions, my real zeros at the top. -1 and 2. And the thing to notice here is that -1, it bounces. So we talked about it being repeated. Okay? So what this means for us is we found 3 real solutions. So I'm going to write that on the side. This has 3 real solutions. There are 2 other solutions. Those 2 other solutions are imaginary solutions. Okay? And we're going to talk about how to find those imaginary solutions. So I'm going to delete out my graph there, and we are going to go and find those 2 imaginary solutions. So the way you find your imaginary solutions, you take your real solutions and you use them in synthetic division to simplify the polynomial as much as you can. So I'm starting with -1, and I'm going to run through that synthetic division. And the main thing you want to notice here is if you're doing the synthetic division correctly, you will end up with a remainder of 0. So I broke down our polynomial once to get this result. What I'm going to do next is I'm going to use that result, and I'm going to do my other solution of -1 since it was repeated. So the difference with this synthetic division is I use what I left off with in the last synthetic division. So I'm going to run through this. Negative 1, 2, 2, 4, negative 4, negative 8, 8, 0. So I ran through two of my solutions, both the negative ones, since they were repeated, and I'm going to finish off simplifying by going through with my solution of 2. And again, I use what I left off with in the last synthetic division. So it goes 1, 2, 0, 0, 4, 8, 0. Okay? So to explain why I did all this and what we're getting to, I just want us to understand we started with the degree of 5. This first result would be a degree of 3. This would be a degree of 4, then a degree of 3. This last result has a degree of 2. So the way I would write this 1, 0, 4 as an equation is x squared plus 4 equals 0. And I'm going to solve that because that simplified our polynomial as far as we can go. So to solve this, I'm going to subtract 4 from both sides. X squared equals negative 4. I'm going to square root both sides. So x ends up being, when we square root, it's always plus or minus. Square root of 4 is 2. And it's remembering when we take the square root of a negative, we pull out I. Okay? So I am going to erase out this part right here so I can write the rest of my solutions. Okay? So the rest of my solutions, I got my reals, I got my imaginaries. 2i, negative 2i. So this is all about understanding how many solutions we know to look for, figuring out how to find the real ones from a graph, using those real ones to break down our equation with synthetic division and find the imaginary solutions if there are any. Now, if the graph showed you all 5 solutions, all you would have to do is use the graph to find all 5 solutions. But you've got to know how to break it down using synthetic division and solve that equation at the end. Again, the first 4 lessons of this unit were vital to this. If you didn't understand those, it's hard to do this right now. 2. So, I really just want you to focus on examples with practice that cover examples 1 and 2. So essentially, I'm using this lesson just to show you example 1 and examples 3 and 4. As far as the time crunch goes, these kind of get cut out.